Alright, in this video we will look at three different types of functions. We'll look at linear functions, exponential functions, and quadratic. In the back of your packet, I have this table in like the last few pages. You can see on here that I have a linear graph, so you know it's just a line. Notice that the line is just increasing, or if you had a line that's just decreasing, that's also linear, so it's either going up or down. You have this is an exponential function, so it just increases really fast. And then in a quadratic, it decreases and then increases again. It could also increase and then decrease again. But the key for exponential, that it increases really fast. So for example, I have a table here. You can see that this is just going down by 1. It's just, we're increasing it by a constant value. I'm just adding the number, okay? In this one, it's increasing pretty fast. Also, you could see here that when you have an exponential, it's basically you have the x in the exponent. So let's say I have 2 to the 0th power, this is 0, is equal to 1. 2 to the first power is equal to 2. 2 to the second power is equal to 4. The base is the same, but the exponent is what's changing. 2 to the third power is 8, and then so on. 2 to the fourth power is 16. So that's how you can tell it's an exponential function. It's like increasing really fast. On this one, you see how it decreases, decreases, it decreases, decreases, and then it increases. It changes direction. So that's how you can tell it's a quadratic. All right, back to our example. On this one, it says on day 0, the company earned $3,000, and then each day it increased by 5,000. It's only increasing. So if it's only increasing by just one number, then this is how you can tell that this is linear. The second one, this is a exponential function. It's basically what I just did in the previous page. And then here, this is a quadratic. Now, on this graph, we only see it increasing, but it's just, it could be exponential, but it is going to actually be a quadratic because of the values. Okay, so this is going to be a quadratic. Not a good explanation for quadratic, but in this situation, we'll say it's quadratic. There'll be other situations I can probably keep, looking at them. But for number 2, it says select the correct answers given. So here's another way that you can tell what type of functions there are. This one right here, because you have the squared here, this is a quadratic equation. Here, because you have the x in the exponent, this is an exponential function. And then here you just have x, and then you're just subtracting. This is a linear. Okay? All right, so which two statements are true? Let's see. F of x and g of x have the same range. So the best way to do this is just to graph it in Desmos. So let me go ahead and graph f of x and look at the range for that. Because I'm only just picking two correct statements, I just have to go through each one and pick the best one. Okay, so here's f of x. I'm going to just press the home button. It looks a little weird. Did I do something? Oh yeah, I put an x here. It's supposed to be squared. There you go. That looks like a quadratic. And then g of x is equal to 2x minus 1. Okay, so here the range is from -3, right? The range is from -3 up. And here the range, it looks like it's at -1. Okay, so they do not have the same range. So I'm going to go ahead and cross this out. That cannot be it. Okay, so actually let me write this. Let me say that this is false. I'm looking for true statements, right? All right, f of x, g of x, and h of x all have the same domain. Let's check. Okay, I already have both of them here. Let me go ahead and type h of x in. All right, the domain for f of x is all real numbers. For g of x is also all real numbers. It's going to the left and it's going to the right. And h of x is also all real numbers, going to the left and going to the right. So this is actually true. H of x and f of x and h of x have the same y-intercept. Let's check. F of x y-intercept is at 1, and then I don't see another one. The other graph, no, the y-intercept is not at 1. So, or h of x. No, the y-intercept is at -3. So this is also false. Both have a minimum value. F of x has a minimum value of -3. Well, that's true. The lowest value here is the y value, which is at -3. So that's true. Okay. All right, next one. The graph of ax squared is shown if a is less than b. Okay, so basically we're looking for this number right here. Okay, which graph would best represent b of x squared? So basically what's happening here is this number b is bigger than this number a. So a is a smaller number. Okay, so we can kind of look at a graph and see what happens. So I'll take this off. So I have f of x equals ax squared, and then I have g of x equals bx squared. Okay, so remember that I said that a is a smaller number, so I don't know, I'll just pick some number. I'll keep it at 1, or I'll keep it at 2. And then b, I'll put a bigger number, I'll just put 3. Let's see what happens. So it looks like f of x, which has the a, is in the green, and b of x, or g of x, it has the b. So it gets skinnier, right? So that means that I'll go ahead and choose a. It didn't move up and down, it just became more narrower. All right, so the next two questions, we're going to closely look at the how the functions are increasing or decreasing. So we're looking for a quadratic. Remember, the values will increase but not as fast, or decrease but not as fast as an exponential. So you see here it's going up by 200, and it's going up by 300, and this would be 400. So this is definitely a quadratic. Okay, and then here this is going up by 10, so this is linear. This is going up way too fast. This is an exponential, and then this is going up down by 100. This is decreasing by 200. This is decreasing by 300. So this is another quadratic. This is decreasing way too fast. So I'm going to be it's going to be an exponential. Okay, so that's the two quadratic. And then the next one is going to be a table below represents 5 different functions, which 2 could be exponentials. So you remember that exponentials, they increase pretty fast, like table 1, and then table 2 as well. This is a linear, and maybe a linear as well. Okay. All right, guys. Thank you.